Dear students, good morning, namaste. This is the fourth part of sequences, chapter sequences. Already I uploaded three parts. That is, the first part is sequences, series, their definition, the differences. Okay, now with examples. Next, 2 and 3 parts are related with the exercise 9.1. Now we are going to start the 9.2. Okay, now? Here we have to know some definitions. That is, you see then observing. Sequences are of several types. Several types means some types. Some types are called arithmetic progression, geometrical progression, harmonic progression, arithmetico-geometrical, arithmetico-geometrical progression, AGP. Okay, now you see sequences with commas. Sequence is a group of numbers. Okay, now already once again we repeat that one. Sequences means a set of numbers, a group of numbers with commas are there. Okay, now? Yeah. But maintaining each term, a definite rule is there. According to the rule, the sequences are of 4 types. Here only 4 types I believe. Many types are there. Leave it out. Mainly 4 types. That too, the 4th type AGPs are also not there. Only the 3 are there. Okay, Nanda? In our syllabus. Arithmetic progression. Progression, sequences, series, all are same. But the difference is there, sequence and a series. Series means connected with, each term is connected with the plus, minus, or plus or minus. Okay. But progression, series are same. The progression, the series, it is also called as a arithmetic series, geometric series, harmonic series, or sequences. All are same. Different names for. Okay, leave down. Arithmetic, geometric, harmonic, arithmetic, geometric progression. Or for some time, you leave this one. You write on your notes and you forgot this one. The main is these 3. AP, GP, HP. Arithmetic progression, geometric progression, harmonic progression. These are with 3 different rules. One rule with AP, another rule with GP, another rule, one more rule with the AP. Only very different, very simple concepts. But all are called as sequences. Okay, now? Once again you see, sequences means set of numbers, group of numbers in a row with commas. Okay, now? Each and every number, okay, now, term is maintaining a perfect, a definite rule. If that, according that rules, these are of 3 types. Okay. Very simply you learn it. These are definitions only. Now we come to the first one, arithmetic progression. Arithmetic progression. A sequence. It is first of all, fundamentally it is a sequence. A sequence A1, A2, A3, dash dash, AN. I am taking a finite series. That means the number of that elements, the number of those terms in the sequence are limited, are finite one. We can count it. That is the meaning. It is a finite series. A1, A2, A3, dash dash, AN. That sequence is said to be called as AP, arithmetic progression. That is the abbreviation. If, what is the condition? The nth term is equal to, before that one, a previous term plus a constant D. Okay, na? Here A1 is the first term. Of course, A2 is the second term. Okay. And D is a common difference. D is the common difference. It is a common difference. Okay, na? That means each and every term of the, except the first term, each term can be obtained by adding a constant number to its previous number, to its preceding term. Okay, right? A5, suppose n is equal to 5. A4 plus some d constant. Like that, each term can be obtained. So that is the difference of any two pairs, successive pairs, not any numbers. 2 minus 1 is constant. A3 minus A2, the same constant. A4 minus A3, here is seen an minus an minus 1. It's okay na? An minus 1 is equal to d. This is also written as, say, in the terms notation, Tn is equal to Tn minus 1 d, or d is equal to Tn minus 1. Like this also is there. T means term. Here it is 5 minus 4. T5 minus T4, the same d. T7 minus T6, the same d. T8 minus T7, the same d. Must be same. Okay, na? So each term with can be obtained by adding a constant. Okay, na? That is called as d. Or otherwise, d is the difference of any pair, any successive pair of two terms. The difference of any successive pair of the two terms is same. That is common difference d. Okay, right? Or simply you learn this definition. What is the progression? What is the arithmetic progression? Means it is first of all a sequence. That is A1, A2, A3 dash and An. Okay, now if it is called as AP, then An is equal to An minus 1 plus d, or Tn is equal to n minus 1 plus d, where d is equal to an minus 1, and also it is called as a common difference. We see one example. 1, 2, 3, 4, dash, dash, 20 or 25 or 100, whatever it may be, you take it. 100, okay. We will take 100. Okay, na? Is there a P? Here first term is T1 or A1 notations. That is 1. D is what I told you there, T2 minus T1, first difference, you take it. The first pair of successive terms is 1, 2. Next is 2, 3. Not 1, 3. Successive pair. Okay, na? It is 3, 4. 4 minus 3, or 3 minus 2, or 2 minus 1. We get only 1. So here d is equal to T2 minus T1 is equal to 2 minus 1 is equal to 1. Wherever you see, the difference is only 2, only 1. So it is called as L. Okay, now? One more example. 2, 5, 8, 11 is also an MP. You see, how can you find whether it is AP or GP or HP means? You find first D. D is a common difference. It is a common difference. CD. It actually CD. Common difference is T2 minus T1. 5 minus 2, 3. Or 8 minus 5. T3 minus T2 also. Not T3 minus T1. The successive two terms. Pair of two terms. The difference of successive a pair of two terms is the same. 5 minus 2 or 8 minus 5 or 11 minus 8. All are giving the same. Here you see, this is 3, is 3 and is 3. All are same. Throughout the progression, throughout the sequence. Then it is called as the AP. I think it is clear. I hope it is clear. Okay, now? It is simply you learn this one. Okay, now? The general form of AP. What is the general form? The general form you see, the general form is A comma, first term. A plus D. Okay, na? A constant is added. Okay, na? In this one. A plus is for the second term. The second term can be obtained by adding a constant D, the first term. A plus D. Next, A plus D plus D. That is A plus 2D. Third term you see that. Third term A plus 2D can be obtained by adding the same D. Here T1 is equal to A. Okay. What is T2? T2 is A plus D. It can be added D. What is T3? A plus D. That means second term plus D. What is second term? What is second term? Second term is A plus D. Again D is there. So it is A plus 2D. So each term can be obtained by adding a constant D to its preceding term. Just preceding term. A plus D. Again A plus D added one more D, A plus 2D. Again A plus 2D added the same D, A plus 3D, A plus 4D, A plus 10D, A plus 100D, A plus 101D. Like this, you see, this is a general term, A plus N minus 1D. You see that? I will tell again. Okay, now you write all these things. Is it okay, now clear? Yeah, just pass. Okay, other. So, from the sequences, we learn about the progressions. Progression is nothing but sequence. That progression are of 3 types. 4 types mainly. You learn 3 types. AP, GP, and GP. AP, what is AP? We learn it. We know that definition. The general form of AP is A comma, A plus D comma, A plus 2D comma, A plus 3D, and it's going on up to A plus N minus 1D. How we can get this nth term, you see. You see, here it is T1 N, T2 is A plus D. T2 means A plus D. That means A plus 2 minus 1D na T2 second term. What is T3? A plus 2D. 1, 2, 3 third term. This also can be A plus 3 minus 1D na. Okay na? 3 means 3 minus 1. Second term means 2 minus 1. T4 is A plus 3D actually is there. So A plus it is 4 minus 1D na. This 3 can be written as 4 minus 2 can be written as 3 minus 1. Okay na? Similarly, we can T suppose 10 is there. A plus it is 10 minus 1D. Okay na? 4 means 4 minus 1. 10 means T10 10 minus 1. Tn is equal to A plus N minus 1D. So is a general or nth term. We may call it as a nth term of AP. The next onwards we use the not numbers term. It is nth term. The nth term of AP is nothing but Tn, that is A plus N minus 1D. Okay now, this is nth term. You see, one example. So here it is a general form. From the general form, nth term is A plus N minus 1D. You learn it. 2, 5, 8, 11, dash, dash is there. Is array. We know it. Already we take one example. It is a array. This is A. Because T2 minus T1, 5 minus 2 is 3 na. 8 minus 5 is also 3 na. 11 minus 8 is also 3 na. So it is AP. One AP. Yes, okay. Here A is equal to 2. And D is equal to, every time you write it. D means T2 minus T1. You take the first pair one. That is 5 minus 2 is equal to 3. So D value. This is A value. First term D must be needed. We are asked to find, suppose, what is T10? That means 10th term. 10th term. What is that 10th term means? We said is A T10 notation, it is A plus 9D. Will you agree? 9D, like this. Or otherwise, one time you write it. 10 minus 1D. That is A plus 9D. That is A is 2. 9 into D means 3. It is 2 plus 27. So it is 29. In this one, can you find by writing the 10th term? 10 terms we have to write it. Okay, now simply by using that 10th term notation, nth term notation Tn and the formula is A plus n minus 1d. T10 is A plus 9d. Easily we can find the 29. That is 10th term. Suppose 100th term. Okay, now T100 means it is A plus 99d na, by using this formula. A is 2. This is 99 into 3. That is 2 plus this is 27 to 29. That is adding 2 for 2, 7, 9 is 301. Okay, Nana? Like that we can find the 100th term. Okay, na? It's correct, 29 not 3 not. It is 299. Okay, na? If 2 is added to this one, 299. So the 100th term, is it possible to find the 100th term? We have to write 100 terms. If we are asked to find 1000th term or any number, it's very difficult to write on the board and on your notes to find that one. So by using this formula, easily we can find it. Okay, now? So what is arithmetic progression? We can understand. We know it well. And the general term of AP, arithmetical progression, is Tn is equal to A plus n minus 1 into D. Okay, then? Yes, it is clear. Now, observe. It is important concept. Finding sum of n terms of a is very, very important concept. It's formalized there. Please observe it. Finding sum of n terms of a. You see, proof. Let a comma a plus d comma a plus 2d comma dash dash a plus n minus 1 d is Aryabatta. We are considering general term. With the general term I am taking a comma a plus d comma a plus 2d comma dash dash a plus n minus 1. We know it. First term, second term, it can be added with a constant. Third term again with d added. A plus d plus d, a plus 2d. Like that, the nth term is a plus n minus 1 into d. Okay, now? Right. This is an AP, we know it. Here we have to find the sum. Let the sum of above AP be Sn. Sn. Tn means 10th term, nth term. You see, Tn means nth term. Whereas Sn means sum of n terms. Okay, now this is notation. It's very simple. Notation. So Sn is the Hence, Sn is equal to A plus D plus A plus 2D plus dash dash A plus N minus 1 into D. Okay, then? See, this concept is a different one. We are finding to the sum of n terms of n. AB is there. AB means progression, arithmetic progression. Set of terms are there, set of numbers, n numbers are there. But we have to find their sum. First term plus, second term plus, third term like that. We have to write all the n terms and we have to add it. That sum is, what is that sum? Nth term is a different one. If you take all the terms and we have added, that is Sn. Now, what is it with the plus I am adding? Okay, no? Yes. Yeah, absolutely. How many A's are there in each and every term of n terms of the series of the progression? A is there. In the first term, A is there. In the second term, A is there. Third term, A is there. 10th term, A is there. In the nth term also, A is there. So, how many A's are there? N A's are there. Okay, na? You agree? Yeah. A, second A, third A, fourth A, nth A. Are adding all A's. How many A's? 10 A's are? If 10 A's are there, 10 A. If 11 A's are there, 11 A. If n A's are there, n A. Yes, okay. Now, how many D's are there? In the first term, D's are there. The second term, third term, D's are there. So, it is D plus 2D plus 3D plus dash dash n minus 1 D is there. Okay, no? Because D is different. It is NA. Don't confuse that. First D, D, 2D, 3D, 4D, 5D, n minus 1D. All pluses are there. And then D as common. So here is a 1D. 1 plus 2 plus 3 plus dash dash n minus 1. You agree? It is NA plus D of the sum of n natural numbers. I want to add n and subtract n. Will you agree? Simply I am adding n and subtracting n. It is NA plus D into 1 plus 2 plus 3 plus dash and dash plus n. In the math, the second chapter after trigonometry, in all 3 sections, I taught the one chapter, that is mathematical induction method. Is there there we used the sum of n natural numbers. Formula is there. Okay, na? So here it is n of n plus 1 by 2. Now, will agree? You see, na? 1, 2, 3, dash, 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 plus n is there. I am adding n and subtracting n. Nothing will happen. So, sum to n natural numbers, n of n plus 1 by 2 is correct? Yeah. Minus this n is there. So, it is NA plus D of n into n square plus n minus n minus 2n. It is 2n. Will agree? LCM 2. LCM 2 is there, 2n by 2. So it is NA 2NA. I will let otherwise let it be 2NA plus D of n square minus n. Will agree? N square minus n minus 2n means minus n. Totally by 2 now. I will write here. It is 2NA or n will 2NA plus. Here I want to take n d of n minus 1. 1n is taken as common. Don't confuse that. This is a sum to n terms n of n plus 1 by 2 minus n. Formula is n of n plus 1 by 2. Suddenly here changes. It is a formula. sum to n natural numbers. Sigma n is equal to n of n plus 1 by 2. Some of you suddenly, you can confuse, suddenly how it come. That is a formula, that formula. That is taught in that second chapter. Already it is over. Okay, leave it out. Here, n square plus n minus 2n LCM by 2. Again, this 2 is taken LCM, totally by 2. 2na plus d. Here, n minus 2n is minus n. Again, I am taking n as common. N means n d. Here, 1n and 1 is there. No confusion. By 2 is there. Okay, now? Again, I am taking n by 2. Here n is common. N is common. By 2 also common. So here it is a plus, not a. If you take n as common, 2a is there. 2a plus n minus 1 into d is there. Okay, na? n by 2, 2a plus d of n minus 1 is there. Okay, na? So, here is Jeremy. You see, Sn is equal, the statement, this one. Sn is equal to, it is n by 2 of 2a plus n minus 1 into d na? Yeah. It is n by 2, 1a, you write it. Another a plus n minus 1 into d na? It is n by 2, a plus, this is a tn, will agree? Tn, last term. Tn, nth term. 2a can be written as a plus a. I am taking a to this side. A plus n minus 1 into d. That will become as a, okay, total. This is nth term. Total, this one is a nth term. Will you agree? This is a first term. So, here you see the sum to Sn. That means sum of n terms of AP is Sn is equal that n by 2. Okay, na? A means first term. It is a first term. Okay, na? It is a first term. I will write again. It is one notation, a plus l, where a is equal to first term, l is equal to last term, with one notation, simply. So, sum of n terms of AP is nothing but n by 2. N terms are n by 2. A plus l, first term plus last. A plus l means last term. Suppose yes, 100 by 2, first term and last term. The last term is not 100. It is according to the AP, that is based on the difference, D, common difference. So it may be some other number, not only 100. It is not a fixed one. Okay, Rena? Like that we can find the sum to n terms, sum of n terms of n. This is the important concept. Okay, na? Yeah. Fast.